Hey everyone, welcome. Today, we're going to talk about Kotlin. But this isn't just about another programming language. Nope. We're looking at it as a direct answer to some of the most annoying, persistent headaches in software development. So let's dive in and see how Kotlin is really built to make our code better and our lives, well, a little less frustrating.
But before we get to the solution, let's talk about the problem. Let's be real for a second. It doesn't matter if you're a seasoned pro or just starting out, we've all had those desk-flipping moments. So what are the things that just consistently drive us crazy as developers?
You know what I'm talking about, right? Those crashes that come out of absolutely nowhere, code that you wrote yourself, but 6 months later you can't make heads or tails of it, and of course the infamous pyramid of doom you get from tying a bunch of asynchronous tasks together. These aren't just little annoyances, they're huge roadblocks that stop us from building amazing things.
Okay, let's start with that first one. Cluttered, hard-to-read code. There's a saying that we spend way more time reading code than actually writing it. And if that's true, then making our code clear isn't just nice, it's absolutely critical.
Here's a perfect little example. It's a classic trap for any Java developer. You've got a string like 12.345, and you just want to split it by the dot. Simple, right? But you run it, and you get nothing, an empty array. Why? Well, because the split method is secretly expecting a regular expression, and in regex, a dot means any character. It's a tiny detail, but it shows how easily ambiguity can turn into a bug.
And that right there, that quote, gets to the very heart of Kotlin's philosophy. Being concise isn't just about typing less. The real win, the big deal, is that cleaner, more expressive code is just plain easier to understand when you look at it. That means less mental gymnastics for us to figure out what's going on, and that is a massive productivity boost.
All right, let's tackle the next big headache. And trust me, this one is an absolute monster. It's been called the billion-dollar mistake for a reason. It's behind countless app crashes. I am talking, of course, about the dreaded null pointer exception.
So take a look at this number. Just 30%. What do you think that represents? It's not just some random statistic. It's a number that tells a really powerful story.
That is the percentage drop in null pointer crashes that Google saw in its Home app just by deciding to use Kotlin for their new features. A 30% reduction. That is a gigantic improvement in stability, all from switching languages.
So how on earth does Kotlin pull this off? Well, the magic is called null safety, and it's baked right into the language. It basically forces you, as the developer, to decide upfront what's allowed to be null and what isn't. And if you mess up, the compiler catches it before you can even run the code. An entire class of bugs just vanishes. Poof!
Okay, on to our final beast, concurrency. Getting our apps to do lots of things at once is non-negotiable these days, but actually getting it right without creating a huge mess has always been incredibly tricky.
If you've ever done any kind of async programming, you've seen this. You almost certainly have the scars to prove it. Every new task gets nested inside the last one, and pretty soon you've got this deep, ugly pyramid of code that's a total nightmare to read and an even bigger nightmare to debug. And the old school way of handling this on the JVM using threads has its own set of problems. See, system threads are heavy, they're expensive, they eat up a ton of memory, and making the system switch between them costs a lot of overhead. You can't just fire up thousands of them and expect your system to keep up. It'll grind to a halt.
And this is where Kotlin plays its ace in the hole. Core routines. The best way to think about them is as super lightweight threads. They're so light you can launch tens of thousands of them and your system won't even break a sweat. It's a much more elegant way to handle all this async stuff. Now look at this. This diagram says it all. On the right, the code looks simple, it looks sequential, it's just one step, then the next, then the next. There's no nesting, there's no pyramid of doom. It reads like it's happening in order. But behind the scenes, it's doing all its work asynchronously without blocking anything. It's the best of both worlds.
So this clean, sequential style is fantastic when everything goes according to plan. But what happens when things go wrong? In the old way of doing things, an error could just get lost, leaving zombie processes running in the background, leaking memory. Kotlin's answer to this chaos is this really powerful idea called structured concurrency.
So, check this out. By default, coroutines live inside this parent-child structure. Now, if one of the child tasks fails, like you see here, it doesn't just die quietly. No, it immediately tells its parent, hey, I failed. And the parent then turns around and cancels all the other children. This fail-fast approach is amazing because it means you never have orphaned work just hanging around. But what if you don't want that?
What if one task failing shouldn't bring the whole house of cards down? Well, that's where something called a supervisor comes in. It changes the rules of the game. Now, as you can see here, when a child fails, the supervisor basically contains the blast. The failure is handled, but its siblings get to keep on working. It gives you incredible fine-grained control over how your system handles errors.
So, what happens when you put all of this together? You've got the clarity, you've got the safety from nulls, and you've got this incredible power of structured concurrency. What you get is a fundamentally more productive and, frankly, just a less frustrating way to build software.
So let's just recap the big wins here. Kotlin makes your code safer by killing a whole category of crashes before they happen. It's more concise, which means our code is easier to read and cheaper to maintain. And its structured concurrency tames the chaos of async programming. Put simply, it's a pragmatic language. It was built by developers for developers to solve the problems we actually face every single day.
And all this brings us to one final big picture thought. By focusing so hard on things like developer happiness, safety, and clarity, Kotlin isn't just offering us another programming language. It's really proposing a better, smarter way to work. So the real question we're left with is this. Is this the kind of thinking that's going to define the future of how we build software?